Inequality section. So everything up until this point was a bit of a review for you. So here we go with linear inequalities. All right. So what does that mean? That it doesn't always lie on the line. It's going to be sections, okay? Entire sections of your pane. So when dealing with inequalities, we use these symbols instead of an equal sign. Inequality does not only deal with the points located on the line, okay, it not only deals with the points on the line, and I'm going to use a different color for that one, but also with the points that are either above or below the line. That's how this is different. And we indicate this by shading, okay? We indicate this by shading the area or the panes above and below the boundary line. And I will explain a lot as we go through this, through the notes. So, example, the inequality, how do you know this is an inequality? Because of that symbol right there. Right? This inequality would have a boundary line of, watch this is copy-paste, except for it now has an, right, this is now an equation. Because of that equal sign. So this is the boundary line that we're going to use to analyze this inequality. So yes, we do go back to linear equations after all. Splitting the coordinate plane into two panes. So this line is going to split your pane into two halves, not halves really, but two sections. Okay? So keep that in mind. In this unit, we will shade using regular or reverse shading. And this I made up. Okay, reverse shading is just I made up, but it's going to make our lives a lot easier. So this is the most popular, okay? Most popular method, especially when you're doing this on paper. When you're graphing on paper, you want to use reverse shading. Okay? What's the difference? Here it is. Okay? For regular shading, we shade the true region. All right? I'm going to use a different color for the other side. When it comes to reverse shading, we shade the false region. That's the difference. Okay? So here it is. I'm going to draw a line. I'm going to use a red pen for the line. Get a ruler for this unit because there's going to be a lot of lines that we're going to draw. Straight lines, morning. So let's say you had a boundary line that goes like this. Okay? And we're going to copy this one. This line that we just created, page 17, if you just joined us, this line, we're going to copy that over to this pane here. These are identical graphs, okay? Exactly the same graph. Every time, morning, page 17, every time you have, this is your boundary line, okay guys? One of the, either above or below, one of them is going to be the true region. Let's just make it be up above here. If this is the true region, what is this going to be? There's only true or false. There's only two options. If this is true, automatically, this is your false region. Listen carefully to this one. So we're going to copy this. This is the exact same graph again over here. So we're going to write down true and false as well. True and false. I'm not going to bother with the region part. Right now I'm just going to go true and false. When you do regular shading, we shade the true region. Okay? So the true region is in this case above this boundary line. So you put your ruler right against that line and then just lightly shade in. Page 17, you're still looking for it. If you're anything like my kids, I'll say it one more time. Page 17. You never told us to clean up our room. I only said it 2 times. You're right. I should do it 3 times. True region is shaded. I'll say this: textbooks, you Google this topic, they're always going to shade the true region. However, I like to shade the false region, and I'll explain to you why a little bit later. Right now, you're just going to have to trust me. What has changed in terms of, has the true and the false region changed, folks? The true has remained the same on either graph. So that is what I want you to focus on. If you can just focus on, hey, the true region is above the line, or over here, the true region is still above the line, that is something to remember, okay? I'll just make a note in between. Note. True region never changed. Okay? This is just like a little hack that we're going to use to make our lives a lot easier. And that will be coming a bit later once we do systems. So if you ever say, Mr. Dirksen, I like to stick with regular shading, I'm actually okay with it, but I would warn you it's going to make it complicated once we have 2 or 3 inequalities at the same time. You're going to shade here, you're going to shade there, you're going to shade everywhere, and you're going to be like, what's going on here? It's so messy, right? So if you do reverse shading, you get rid of that problem. Okay, next. I'll highlight it one more time here, this part. The true region does not change, okay? One more time. The next part is a dashed line versus solid line, right? So you might have a line, a boundary line that is dashed and one that is solid. And this is what you have to look for. The symbol. Is it just less than or greater than? Or is it less than or equal to, greater than or equal to? That is what makes the difference. If it is this, if the symbol is like that, I'm going to make it, the boundary line go up this time. You would immediately say, okay, this is a dashed boundary line. And that is an indication to your audience that a point that is on the line itself is not acceptable. Okay? That's what this is saying. If you have the equal sign underneath the inequality, it's solid. That's all I'm going to do there. I'm not going to make it. Maybe I'll just highlight this part. Points on the line are not included in this part. Here, points on the line are included as part of your solution. Because guess what? Your solution, points that are acceptable are going to be in the true region. And in this case, it would not be including the line itself. In this case, it would be. Any point on the line itself, as well as in the true region, would be a potential solution to your inequality. Let's keep going. I had a student that graduated, went to university, came back, said, Mr. Dirksen, do you have the notes on inequalities? Because it came back and required math course, and it was interesting. Something that happened in grade 11 came back in university, right? So keep your booklets, I would say, for now. Don't make a campfire just yet. Page 18, rules on working with inequalities. Okay. Watch this. When multiplying or dividing inequalities by a negative, we need to flip this symbol. Okay? So when multiplying or dividing by a negative, you need to flip that inequality symbol to keep that statement true. Okay. So if I asked you, when you have an inequality, you kind of are asking questions sometimes if there are numbers on both sides. Is 2 less than 5? That's what the statement is saying. And the answer is yes, this is true. This is true. But let's say I took this inequality and you divided both sides by the same number. I'm going to choose -1. If we chose to divide both sides, divide by -1. Because technically you can do that. Whatever you do to one side, you do to the other side. What do you get if you do that? 2 divided by -1 is -2. 5 divided by -1 is -5. Would it be correct to keep the inequality the same way? That would now be incorrect. Okay? This is false. This is false, right? Therefore, we flip inequality symbol to make that true. So what you need to do is, if you do that, if you at all divide or multiply by a negative, you come in there and say, well, it used to be this way, correct? So it's going to face the other way now. Okay? Flip the symbol, and then you're okay. I'm going to give you another example here. How is this going to play out in what we're doing? So sometimes this is an inequality that you may encounter. Let's say you have that, and I'm going to ask you to rewrite it where y is isolated. So guess what? We're going to bring this 3x over to the other side. So you end up with -2y is greater than or equal to. The 3x is negative. What happens when you flip, when you come over to the other side? It turns positive. The 10 is already on the right side, so nothing changes to it. What would you have to do now to get rid of the -2 in front of y? You divide by -2. You get y, and what would you do with this symbol immediately? You change it, because you're like, hey, wait a minute, I'm dividing by negative. I'm going to flip, so I'm just going to make a note here. Flip. I repeat, this only happens if you divide by a negative. If this had been a +2, don't do this. Don't do the flipping if it's a positive. Okay. So this would be what? 3 divided by -2 is -3 over 2x. Positive 10 divided by -2 is -5. Okay. So that's what I mean by that. And I'm just going to write down that this is a very important concept. Okay? Very important to know this part right here. It can, like negatives in general, it can really affect your answers. You got this? Okay, so let's continue. So let's focus on this middle part here. Determining the true region, right? I'm going to talk about test points, and then I'm going to talk about the shortcut. Okay, so this is also important. All of these are very important to know when you do these. Okay, so the graph of the inequality -2x plus 4y less than 16 is given below. Okay, so this is your graph. Let's not answer this part just yet. Is this an example of regular or reverse? We don't know that yet. We need to know where the true region is. I repeat, you need to know where your true region is. How would you know? Okay. So what we're going to do is, this is your boundary line right here. I'm going to write this down at the top. So technically this boundary line should continue. Okay, so this is boundary. I don't want to use up my space here. That's why I'm writing this. This is your boundary line right here. So one of these sections is going to be true, one is going to be false. How do you find out for sure? And this is how we do it, okay? You pick any point here or over here. Like pick any pane you want and pick a point, a random point. And you know how random this is going to be? Not random at all. I'm going to pick this point right here. What is this one? 0, 0. And there's something about 0, 0 that makes your life a lot easier. This is what we call our test point. We're going to check if 0, 0 is true or false. Okay, guys? So, test point, write this down. Test point is 0, 0. So we're going to plug that into that inequality and see what happens. So we go negative 2 times 0 plus 4 times 0, because x and y are both 0. That's supposed to be less than 16. What do you get on the left side, folks? It's just a 0, right? Remember, when you have numbers on both sides, you ask yourself, is that true? That's when you have numbers on both sides, you need to answer the question. Is that true? Yes. This is true. So when you plug in 0, 0, it makes the inequality true. All right? So that means that wherever the test point is, right, is it above or below the line? Right? This is your line. This is below the line, correct? That means that anything in here is also true. Automatically, like if you pick the area below and you plug it in and it's true, you're like, oh, 0, 0 is right here. That means that all of this is true here. So I'm going to make an arrow going back. This is now my true region. You've just determined by picking one point and plugging it in, you've now determined that this is your true region. Does that make sense? Let's look at it this way. If you had plugged in 0, 0 in here and you ended up with a false statement, right? Then that means that this whole thing would have been false. The whole region up below the line is false. Mr. Dixon, could I have picked a point up here and plugged that in as my test point? Yes. It's just going to be a little bit more work, right? You have to compute this. 0, 0 is my go-to. The only exception, listen carefully, if your line actually goes through the origin, do not pick 0, 0. Then you have to kind of go a little bit above or below for that to work. But I'll show you a shortcut soon. If this is true, what does this region then? False. Remember, I focus on where is my true region, and then I know the other one must be false. That's usually my approach. So any point above this boundary line, any point, you can go as high, anywhere you want above it, will always be false if you plug it in. I don't have the space to show you that, okay? Anyways, we got that. What kind of shading is this then? Is it regular or reverse shading? It's regular because the true region has been shaded. Regular shading. I'm not gonna explain why. It's just regular because true region has been shaded, okay? Okay. Here's a shortcut. It's actually quite nice. The shortcut makes it a lot easier. if you isolate the inequality and have y on its own, if you have y is less than or y is less than or equal to, then your true region is below the line. So I say true is below like this. Okay? This is the symbol I'm going to use from now on. If you have y is greater than or y is greater than or equal to, it doesn't matter, it's greater than, then the true region is above the line. So true is above. That's what I'm going to use moving forward, because then we're going to quickly be able to tell just by looking at the isolated form. Let's do a quick graph here just to help you out. So if you have, this is your pane. And you have, this is your boundary line. Doesn't matter, the true region would be here. It's going to be below the line. Let's just do another version of it. Sometimes students think the line is always going to go up if they see that. Let's make the line go down like this. Where's the true region in this case? If the line is this way, it doesn't matter, it's still below the line. So if this is your line, what's below? It's this way, right? So the true region is here. Notice that I'm not shading here, I'm just focusing on the true region because that's really what it's all about. Same thing here, let's do another one for this one. So you could have a solid line going this way. That is your boundary line. True region would be above. And then you have a dashed line here. I just want to mix it up so you don't think it's always going to be a solid line. This is your boundary line. And when you isolate your inequality, which we're going to do all the time basically, you quickly realize that the true region is above here. True. So both of these are below. In both of these cases, it's above. There we go. But then we have our special cases when you only have an x variable. Okay? So then you would have, if it's less than or equal to, it's to the left. Left. So true region is going to be to the left like this. If it's greater than or equal to, the solution region is to the right. So true is to the right like that. That's the shortcut. Okay, so if you have something like this, maybe here I'll just give you one graph of each. Let's see. So obviously if there's only an x, then your boundary line is going to be vertical, and the true region is going to be here. It's going to be to the left. But let's say you have a vertical line like this, and you isolate and you get x is greater than, then your true region is going to be found to the right of that boundary line. Can I just add, I feel like I should give you one more for the y's. You could have a case where it's just y and a number, then it's a horizontal line. So if you don't mind, I'm just going to add two small little graphs. Underneath here. And I'm just going to have a perfectly horizontal line like this, but in different locations, because sometimes you will have horizontal. That's just fine. But if it's less than, then the true region is going to be below the line. If it's greater than, it's going to be above. Okay. So again, everything focuses on these isolated forms. And if right now your head is spinning, it's okay. You're going to add it to your study sheet. You're going to help yourselves wrap your head around it. But to be honest, personally, I would say if after a while, these top two here are going to be everything you need in this case. Just these two. You're not going to need the graph necessarily, if you ask me. Okay. So in it all, one more time, it all revolves around finding the true region first and foremost. Okay. There you go. Now we can start actually graphing these things. Let the games begin. All right, let's go to 19. So the idea is first we're just going to do one at a time, and then we're going to mix it up with two or more. So graphing inequalities. For each of the following, determine the intercepts, rewrite the inequality in this form, and then graph using regular shading. So I will be very specific, regular, reverse. But most of the time, reverse is going to be the go-to once we do more than one at a time. So if you see this inequality, this is the boundary line. The boundary line is actually 4x minus 5y minus 10 is equal to 0. Whoa, what happened here? This is the inequality. This is the boundary line. I want you to, for a moment, forget about the inequality and just focus on the boundary line, because that is the one we're going to graph. And then we're going to switch over to inequality by shading. So this isn't quite the way I want it to find the intercepts. So watch this. What happens to that 10? The 10 comes over to the other side. It comes over positive. That's how I want it before I find the intercepts. So let's do the intercepts. X-intercept, Y-intercept. At this point, you're really good at this. So for the x-intercept, it's 4x is equal to 10. Just watch your signs, please. X is equal to. This is finite, so, and by the way, this is only for you to sketch, so I'm okay you rounding here if you have to. 2.5. So 2.5, 0 is your x-intercept. Y-intercept, negative 5y is equal to 10. We divide both sides by negative 5. Y is equal to negative 2. So 0, negative 2 is that. That's all I need to graph that boundary line. And you'll see I'll shift the way I work with this. I won't bother down the road to write it out with an equal sign. I'll just look at this and just work with it right away, find the intercepts. Okay? So this is step number 1, find the intercepts. Then rewrite the inequality. We're going to rewrite this, isolate. Okay? So we're going to go negative 5y. What happens to the 4x? It comes over, correct? So it'll be negative 4x. And the 10 also comes over to the other side. That is positive 10. Like that. What do I need to do next? I need to divide by negative 5, correct? What am I dividing by? Negative 5. What happens to the inequality when you divide by a negative? Yep, you flip it. So for now, until it sinks in, I'm going to tell you that. I'm going to make that obvious flip. So I'm going to take this and point it the other way. That leaves me with y. On the other side, it's negative 4 divided by negative 5. That's positive 4 over 5x. 10 divided by negative 5 is negative 2. That matches my y-intercept, so that's a good sign. Okay? So this is good. This is how I want it. Here you have to pay attention to this part. Y is less than tells me a bunch of things. Okay? It tells me that this is a dashed line. It also tells me that where is the true region? Is it above or below? You go to your cheat, right? It's going to be on your study sheet. I already know, I've done this so many times. When it's less than, I know it's below. Like, I just remember that. But you might have to say, well, okay, the isolated form, okay, it's one of these two, so true, the true region is below the line. Okay? So then you go back and you tell yourself that. So here we go. True is below the line, the boundary line that I'm about to sketch. Okay? So there you have it. So if you're doing regular shading, where are you going to shade? Shade below line. You're going to match that. You're going to shade where the true is. So watch this. This is my short code here. Dashed. True is above the line. Shade above the line. I actually will stop doing this very soon. I'll just tell myself that dashed, true is above the line, and because I'm using regular shading, I'm going to shade above the line as well. These arrows are going to match. Okay? If it's reverse shading, we're going to actually shade the opposite. Got it? Okay, let's do this. So remember, I give you the template. You may have to fill it in. So arrowheads on all the axes. You put X and Y for now. Later on, that's going to be something else because it's going to be word problems. Okay? And the scale is already set, so way to go. So 2.50 is right here. 0, -2 is right here. You don't have to label them on the grid because you've done the scaling. You show me what the intercepts are, so you're good to go. So you're so used to just drawing your line, correct? But this is a dashed line. So sometimes if you do go solid, all you need to take is your eraser and just erase every other section, and then you get a dashed line. But if you remember, then it's best to just stick with it. This is the inequality. Y is less than 4 over 5x minus 2. Could I have taken the original inequality up here to label it? Absolutely. If that's what you want to do, go for it. Okay. And true is above the line, guys. You've already done the work. So you grab your ruler, place it right against the line, and then just shade everything above that line. See, you thought coloring between the lines would never come back, right? Kindergarten, preschool, now it comes back. Because later on we're going to have multiple lines, so you're going to have to be careful there. If only they gave you a ruler when you were that little, right? This is the most important part right here. Tell me that this is the true region. Everything up here is true. Oh. I just messed up big time, didn't I? I'm glad it happened because it's going to happen to you as well. So this is how you fix it. Sorry, guys. I apologize. But you knew all along I'm messing up, right? You weren't thinking I'm crazy. You're crazy. You're not crazy. I am just bad at. True is below the line, and it's on video. Ay, ay, ay. Good thing I don't have to apply for a job. It's like they would go check out the video. Like, I don't think you should teach. I think you should not teach. True is below, so my bad. Oh, yeah, that's going to be painful, but it has to be done. I need that duck sound here. Sorry. Sorry if I dragged you into this mess, guys. So the lesson from this is make sure you double, triple check. Before you're shading, check. So I told myself truth's below the line, and this is where I messed up, right? I guess because I was talking at the same time, so hopefully that doesn't happen to you. So truth's below the line, my bad. There you go. It's not too bad. Looks all right. There, that's the true region. We would have found out in the next step anyways, to be honest. Okay, so this is the next step here. Is this a complete graph? Yes. You've labeled your inequality. You've labeled your axes. The scale is already provided. You might have to do that later. And you've told me that this is the true region. You're good. Automatically the top is false here. Watch this part, and then you're going to be off on your own for a bit. Is 40-30, is this point part of the solution? Show your work. I don't want you to just look at the graph. Where is 40-30, guys? 40, it would be way off here somewhere, and then way up here somewhere. We're not 100% sure if it is. So let's test for sure. So all you need to do is plug it into your inequality and check. Plug into original, the OG, right? Inequality. Mr. Dixon, shouldn't I use the rewritten form, this one here? It's much easier. But what if you made a mistake? I wouldn't pick that one. I would pick the very original one, this one up here. This is the one I'm going to plug those values into. So watch this. I'm going to copy it just for note-taking purposes. This is what the inequality is at the beginning. So let's plug in these values. 4 times 40 minus 5 times 30 minus 10 is supposed to be greater than 0. And sure, 4 times 40 is 160. This is 150. Minus 10 is greater than 0. This one right here is going to give me 10. Minus 10 is greater than 0. 0 is greater than 0. What's going on there? Is that true? No. 0 is not greater than 0. It's equal to 0. Okay? So this is false. If you, I just need to make sure you understand that. If the original inequality had an equal sign underneath here, then this statement would have been true, because it asks you, is 0 greater than or equal to 0? The or part wins, right? Like it is. But in this case, it's false. Therefore, not a solution. Just like that. Okay? Not a solution. Same here. Let's try this one. 4 times negative 20 minus 5 times 50 minus 10 is greater than 0. This is negative 80. This is negative 250. Minus 10 is greater than 0. this adds up to negative 340 is greater than 0? This is false, right? This is false because it's negative 340. It's smaller than 0, actually. So therefore, not a solution. Sometimes you'll get true. Sometimes you'll get a false statement. You just have to plug in and check for sure. So that's how you would answer this one properly. Don't just say, I don't think so, maybe. It looks like it. Don't do that. Just show me by doing this plug-in method. Okay? Okay, one more example, and then I'll give you some time to work because you need to practice this. Okay? Let's go to 20. I'll give you that special case there. Mr. Dirksen, you're a special case after that example, right? I know. I know. Okay. So watch how I approach any inequality in general. I look at it. You want to rewrite it. You want to have the x and the y on one side and the number on the other side. That's my first go-to. And you notice there's no y variable, correct? You see that? No y variable. So my boundary line is going to be vertical. That's what that tells you right away. Maybe you notice right away, maybe it takes you a little while once you clean this up. So 3x, what happens to this x? It comes over, correct? That's minus x is less than 6. You're just moving stuff. You're not multiplying or dividing by negatives yet. 3x minus x is 2x is less than 6. And you realize at this point, hey, there's only an x there. You are correct. Divide both sides by 2. X is less than 3. Special case. The boundary is x is equal to 3. It's a vertical line. Okay, just so you know, that's a vertical line right there. If you just see variable number, in this case it's a vertical. If you had y is equal to 3, it's a horizontal line where it goes through 3, right? Is this solid or dashed? It's dashed, right? Because of that. Where's the true region? See if I can get it right this time. Yeah, go ahead. X is less than. If you check the cheat chart there, the shortcut, it's to the left. We're also going to shade left. Okay. So I go dashed, true is to the left, shade is to the left. I think I got it this time. Let's get some. So you go through x is equal to 3, and it's dashed, remember that? It goes through 3, 0. There we go. I will label this right away. We label the inequality. True is to the left. And just these are the easiest ones to graph, folks. You don't need to find the intercepts or anything like that. And it's everything to the left, so don't be scared to use up the whole left side there for that. That's it. That is your graph right there. Is 4, 7 a solution, guys? Where is 4, 7? 4, 7 is 4. 7 is up here. Is it a solution? It's false. This is false. I don't know. I haven't been bothering with it, but whatever isn't true is false. So we already know by observation that it is false, but this is how you check for sure. You take the original and you plug in this number. And you might think, wait a minute, there's no 7, Mr. Dirksen, there's no y here. That's okay. All you do is you plug in the 4 wherever there's an x. So it's 3 times 4 minus 4 plus 6. 3 times 4 is 12. 4 plus 6 is 10. That is false. Not a solution. And you might ask, you might wonder, is it always going to be false? No, it's not always going to be false. So make sure you just do the math, figure it out, get to the point where you have two numbers, and then you make your decision whether or not that is false or true. So this is actually just to give you a little bit more, but I'll leave it for now. I'm going to ask you to go to 21. No, not 21. We're going to go to 23. 23. This is what I'm going to do here. I'm going to, because this is fresh, you just watched me do it. It's probably still not sinking in, okay? So I think what I'm going to do is for the first 3, or let's do the first 2, I'm going to group you up, and we're going to do it on whiteboards, okay? And then we'll come back and then continue just doing this on our own on the paper. Once it sinks in, maybe somebody else will have paid attention. And writing inequalities from the graph. So we're going backwards here. This is how we're going to approach this. We will determine our slope, determine the true region. We're going to figure out if it's solid or dashed. And then we're going to write out our inequality, okay? I think I should say that the B part, determine the slope and y-intercept. Can you write that down? Add it to your steps there. So, before we start, the first part is super easy, I promise. If this has solution, that is also the same thing as true. All right? Where's the true region? Or first of all, is it dashed or solid? It's dashed, right? Where's the true region? Above or below the line? Below, correct? So we know that this is going to be y is less than. We know, just based on that it's going to start like that. Y is less than. Would you agree with me on that part? Okay, so you're halfway there. Now we need to figure out the slope. We're going to figure out the slope here. And we're going to figure out the y-intercept and then slap that on to make, because we're going to now look at the boundary line. Okay, what is my slope here? You pick 2 points and be strategic with them. Do you see the 2 points that I kind of gave you? Don't guess, right? This one here and this one here. There's actually 3 points there. You only need 2. I'm going to pick the closest one, even though you could pick the furthest apart, anything you want. So I'm going to go, how many units do I rise? 4 units. Okay. And how many do I run? 3. This is my rise. This is my run. So I have to say 4 over 3. Rise and run. Okay? You get up and then you go to the kitchen to get breakfast, right? That's your slope. However, this is my trick. This is only my trick. Other teachers may not like this. Which way is this pointing? Is this line going up or down? It's going up like this. So I know that the slope is going to be positive. Whereas if it's going the other way, I know I'm going to have to put a negative in front of this. Okay, so this is just telling me it's a positive slope. It's 4/3 positive. If this line would have pointed down, you counted 4 and 3. It's like, hey, it's pointing down. Then it would have had a negative. I just slap a negative in front of it. That's all. So that means that I can continue this 4/3x. And what's my y-intercept? You know that the y-intercept is right here. So this is 1, 2, 3, 4. That y-intercept is 4. So I'm going to go plus 4. And voila, you found your inequality for that graph. We've got 5 minutes. I think we can do this in 2. So let's do one more, because I want you to practice this as well. Is this dashed or solid? Solid. I'll go solid for now, otherwise you're like, S? What's S? Solution is where? Or true region is? Above the line, correct? That's what you want to focus on. So I can start my inequality like this. Right? Is this? I think you would agree with this part. And then the tricky part is the slope and the y-intercept. Maybe I'm going to say slope and y-intercept. B is the y-intercept. Let's do B first. That is, it's hard to tell. It's 1, 2, 3, 4, 5. It's 0, -5 is my y-intercept. So I'm going to go, my B is -5. What is my slope? And I don't want you to guess. You should be able to replicate your slope, right? If you're not sure, try it and see if it keeps going. But I'm gonna pick these 2 points here. This one and this one, or this one works as well. But watch, this is, what's your vertical change? 2, correct? And how many do you run? 3. So this would be a 2/3 slope, but my line goes down, correct? So what's my slope going to be, positive or negative? It's negative. So you got to slap on the negative in front of the 2. That's how you solve that problem. So here we go. It's -2/3 x minus 5. There you have it. There you have it. Okay, so I'm going to say, I want you to do pages 22 all the way, actually, sorry, 23 to 26. That's what I'm going to say. 23 to 26. And some of you already got 23 done today. So that's your homework. Page 23 to 26. Remember, it's over soon, so just stay focused. You can do it.